It is a software built for statistical purpose. It is like in theory statistics, whatever we do, we can do it with this software SAS. Right? So next is like as soon as we start our SAS session, we get to see 5 main windows. One is editor window. This is the place where we write SAS programs. Next is log window. Say for example, once we have written a program in the editor window here and submitted. So in case if there is any error, it will be like reflecting in the log window. Next is the output window. With the output window, we can see the results. Okay. Next is Explorer. If I click this window, these two windows will work independently and this menu bar will change here. So next click on Explorer. As soon as I click on Explorer, I will see libraries, file shortcuts, computer, favorite folders. These three are there to navigate to your system environment. Say if I click this, I will go to my computer. I can access folders over there. Next is libraries. This is something built within SAS. If you click this libraries, by default, if SAS is installed in system, we will see only SAS user, work and SAS help. Okay. SAS user, work and SAS help are SAS built-in active libraries. Right? Next is work. Say for example, I have stored some data on desktop and I will write a program. I will bring the data into SAS, and once I bring this data into SAS, it gets stored in this work library, and once it is inside SAS, we refer it as data set. Okay. Next is results. If I click on this results, here we get a tree kind of diagram. Say for example, in editor I have written about 10 programs and I have got output for all the 10 programs in the output window. Suddenly, while observing the 10th output here, 10th program output, suddenly I will think of first output. If I want to see the results of first output, here we get a diagram, tree kind of diagram. If I click on the first one, it is like SAS will show in this output window the result of the first program. This is how SAS windows work. Okay. Next is, so next to define SAS, SAS is a statistical analysis system. The form is SAS. Okay, to define SAS, I will say it is used to process and analyze different kinds of data. You can work with any kind of data using SAS, and we can process and analyze different kinds of data. We have to write the programs here. We have to bring the data into SAS. Right? So as I said, SAS is statistical analysis system. It is used to process and analyze different kinds of data, and it is a general purpose programming language. When I say general purpose programming language, here it is like we write programs in general. Okay, it is not purely syntax based. Say for example, if we are like, we would have experience with C programming or some other programming, where the programs are purely syntax based. If you want to learn something, you have to like know the syntax. In SAS, it is not like that. It is a very general purpose programming language. Here we have certain programming rules. We have to follow those rules while writing programs. Okay, next coming to data. Data is nothing but collection of some information. Right? Now what I will do here is, I will store some simple data in a desktop. Right? Once I do that, I will come to SAS, I will write a program, simple SAS program, and try to bring the data into SAS, and we will do some basic kind of computation. Okay? So now here what I will do, I will create one text file. I will name it as wins. Next, I will click on this. I will try to enter some data, VINOD, and it is like, I will say, we know here, okay, I will type gender, and next is, I will say, age, next is to visit, then next is I will say 2000. Okay, 25. Next is 2. I will enter some data here. Vinay, M, and then 32, 3, 4500. Next is 3. Next is 3. KIRA, M, N, F, 5, and 5, 2500. Then next is 4. Then SU image 6 and some thousand. Okay. Next is 5. Then I will say then 63. Then 5. Again I will type here 47,000. Okay. Now I have entered all the data in a text file and I am storing this file on desktop with the name wins. So if you see this data, what we can see here, we have just entered some numbers and character values, right? And here the value that separates one data value from the other, here in this case is space. Space is regarded as default delimiter in SAS, right? And vertical columns are referred as variables and horizontal rows are referred as observations. Next is, now what I will do, I will try to save this data. I will go to SAS, I will write a simple SAS program and try to bring this data into SAS. See, the data is here. Fine. Next is start typing the program here. I will say data 1. Next I will say input, in file. In file I am telling SAS where to find the raw data file. For this I have to give the path of the file. Just go here, right click, go to properties and copy this path. Say okay. Come here and you paste here. Then next is, I will say name of the file wins.txt, it's a text file, end with semicolon. Then I will say input. The first variable what we have in the raw data file is serial number. Next is, we have names. Name is a character variable, so I have to use dollar symbol. Next is age. Next is, so we will refer this, we will refer this. So first is serial number, name, gender, age, visit time. Gender, age, visit time. So I will come here. Next is gender is a character variable, so dollar symbol. Next is age. Next is visit. Next is time. End with semicolon. Now you say run. Next is PRS print data equals ONE1. Next you say run. Now you select this program and run. Once you do this, you will get the raw data file into SAS. See here in the output window here. And here I can see one more. This is nothing but your HTML report. Okay. When SAS is installed in your system, the HTML, your browser will be configured with SAS. So within SAS, you get to see HTML report. Next is editor. This is the place where we wrote a simple SAS program. It contains two steps, data step and proc step. There are several proc steps. Proc is nothing but short form for procedures. So your data step starts with the word data, ends with run. With the infile statement, we tell SAS where to find the raw data values. Next is input statement. With the input statement, we will be giving names to the variables. Next is proc print step. Proc print is just one of the procedures that is present in SAS. that is used to list all the observations that is present in this work library dataset 1. If I click this dataset 1, you get to see view table or data portion of a dataset. It looks like similar to your Excel spreadsheets. So whatever is there in this sheet, if you want to bring it to output window, then you have to just select this and run. Fine. So just select this and run. So you got the result in the output window. I said about results window here. It creates some tree kind of diagram. When I select the program and run, for each run you will get a tree kind of representation here. Right? Okay. Next is, once I bring the raw data file into SAS, so this is called as data set and this is view table or data portion of a data set. Now, in the same way, what SAS does is, it uses some of its memory space and it will build something called as descriptor portion of a data set. It is nothing but just like your properties for your text file. If I right click here and go to properties, what do we see here? We see all the details about the text file, whether what is its name and its extension, where it is stored, what is its size, when it was created. It gives all the details about this text file for the data stored in a text file on desktop. Same way, when we write a program and bring some raw data file into SAS, when SAS creates a data set, it will also create something called descriptor portion of a data set. So to see the descriptor portion of the data set, we have to type prop contents data equals, you say 1, you give the data set name and you say just run. If you select this and run, see, I will select this and run. What SAS does, it gives all the details about the data set, where it is stored, which library, and this is the engine. The default engine SAS uses is V9. There are other engines like XML, Excel engine, Access engine. That is all built in, available with the SAS software. And it is like it gives the details when it was created and modified. And here we get to see number of observations that is present in the data set and number of variables in the data set. Next, it also tells about the size. Then next, where it is stored and the OS present in the system. All these details you get with the prop contents procedure. And here, this is very important. Here we get alphabetical list of all the variables that is present in our data set. See, and it also says that whether the variables are numeric or character. Okay. So age is a numeric variable. So it is like we got 8 here. Then amount. Amount again, it is numeric variable, and the default storage length for any kind of data, whether it is numeric or character, it will be 8 bytes. In our further classes, we will get to know about this 8 bytes, how SAS stores the data and what exactly this 8 byte means. Okay. So next is, next what I will do here is like, I will do some simple computation with SAS. See, I will copy the same program here. If I want to modify here, to make things simple and easy to understand, I am just copying and just trying to do some minor modifications in the program. See, I want to compute how much each person has spent. For that, what I will do, I will say to compute total. I want to find out how much each people has spent, each person has spent. So I will comment this statement to compute total, and I will say total equals visit into amount. Right? Visit into amount. Here visit, we have a variable visit and amount. The visit variable values and amount gets multiplied with the amount values and we get the total. So I will select this program and see. Now, okay, there is some error here. See, this part should come after this input statement. You have to see after input statement, you give the comment statement, then you say total equals visit into amount. Now you select this and run. Fine. Now I got total. Total is a new variable. If you want, you just check with this. It has multiplied 2 with 25,000 and we got 50,000 here. Fine. And one more important thing is like if it is a missing value, you get a missing value here. Okay. Next is, see, I have done a simple computation in the data step. Next, we might like get a question that what and all we can do with it. It is like can also generate tabular kind of reports and other reports using different procedures. We can also generate graphs. So now with this data, say for example, you think that we had a very big raw data file with us. We wrote a program and we have brought the raw data file into SAS. Now I want to find out how many male and female were there in the raw data file. So for that we will be using a different procedure. I will say just proc frequency data equals 1. Then next I will say tables. I just want to find out how many male and females are there. For that I have to type tables gender and you say here no cum and no percent, because SAS by default it prints cumulative frequencies and percentages. Here I am just interested in getting the count of number of females and males in the raw data file. I will say here run semicolon. See, select this and run. See, I got to know it is like in the raw data file we have 2 females and 3 males. If you check in the text file, here, it will be 2 females. You can see here 2 females and 3 males. Okay. Next is, say for example, I said you that we can also generate graphs here. So this is like I'm just telling you what and all you can do with SAS. Just a brief introduction, but we can do many more things here. Okay. So proc gchart data equals 1. I will say here. Next I will say v bar. I will say gender, and with semicolon. Next you say here 1. See? You select this and run. See, you got graphs here, and for graphs always SAS prints in a separate window of graphs. Okay, here by seeing this graph we can understand that 2 females and 3 males were there in the data set, and the default statistics for graphs is frequency. Same way you can also create horizontal bar charts. Proc gchart data equals ON1. Next you say h bar gender, and with semicolon, and you say run. For this graphical chart you get statistics also. See here you got statistics. If you don't want statistics, you can just say no stat. Next is, if you want, you can also print pie chart. Proc gchart data equals 1. Next you say here pie, I want 3D chart. Pie 3D. Then I will say gender. Then next I will say here select this. See, you will get 3-dimensional charts. In this, I want to separate this fragment. I want to explode it. So what I will do? Copy this, paste here. And you say here explode explode equals. Within this, you type here You select this and see, you will get like this. You can see it has been separated. Okay, this is all I have for basic demo class. Thank you. Okay, have a nice day.